Hi gentlemen, these are your notes for Unit 3, Day 2 of Pre-Calculus. If you would like to see the warm-up problem, review question, or any homework problems we covered in class today, just look at the finish notes. So today in class we're going to be talking about quadratic functions and how to graph them and describe them by their vertex, axis of symmetry, and intercepts. We're going to be able to write the equation for a quadratic function given key points like its vertex or points that fall on the parabola, and we will be able to find the minimum or maximum value of a quadratic function. So quadratic functions and transformations. So you guys probably remember that the most basic quadratic function would be y equals x squared, and I'm just going to draw that parent function up here. And now you can move that parabola up, down, left, and right, so we could have y equals x minus 3 squared plus 4, and that would move your parabola up 4, so 1, 2, 3, 4, and to the right 3, 1, 2, 3, and it's still a happy, normal looking parabola because I didn't reflect it or make it narrower or wider with a vertical stretch or compression. So that's an example. We could also do y equals negative 1/2 x plus 3 squared. And now this would reflect the parabola because the negative in front. So instead of a happy parabola, it'd be a sad parabola. And this one's just moving 3 to the left. And then that 1/2 makes it wider. So it's going to grow twice as slow. So it's going to be a wider looking parabola. We could also make it a narrower parabola. So we could have f of x equals, and we could do 3x squared minus 4. And so this would be just a happy parabola that moved down 4. So 1, 2, 3, 4. And then it grows 3 times as fast, or it's going to be narrower by a factor of 3. So it's a vertical stretch by a factor of 3. So those are just review of the transformations that we covered in our last unit when dealing with quadratic functions, which make parabolas at their graphs. So vertex form. This is a form that kind of looks like when we were doing circles where the x and the y have a number with it. So vertex form is going to be y minus k equals a times x minus h squared. So notice you have the h and the k again, just like you would do with circles, and it's going to be the opposite of what you think. So if it's like x minus 3, it would actually move it 3 to the right, and if it's y minus k, that would actually move it up or down k. So if it was y minus 2, that would move it up 2. If it was y plus 2, it would move it down 2. Why does that work? Well, if you look at this problem right here, this guy looks like he's almost in vertex form. So if I took it, and all I would have to do would be to subtract that 4 over, and then he's in what we would call vertex form. And in this case, the a would be 1, which means that the parabola would just be normal looking. It wouldn't be narrower or wider. And so that minus 4, I moved him over so that it looks like y minus k. But if I added it back over to the other side, then you would see that plus 4 would move it 4 up. So that's why it's going to be backwards thinking on this. So in this case, the a would be 1, so it's not narrow or wide. So that a is going to do the vertical stretch or compression. So that's vertex form. So if I had a parabola like y minus 2 equals 1/2 x plus 1 squared, instead of calling it the center of the circle, what we're going to do is we're going to call that point the vertex of the parabola. So the vertex of my parabola is going to be at the point hk. So in this case, it's going to be at negative 1, positive 2. So if I were to graph this parabola would start at the point negative 1, 2, and then it's just a wider, happier parabola. And that's vertex form. So if a graph is not already in vertex form, then we've got to do what we did to the circles. So if you remember when we had that circle in the ugly form and I showed you guys how to complete the square, that's one option on what we can do. So option 1 is we can do what we did with the circles. So the first thing we're going to do is we are going to move the 5 over. So we're going to do, this is going to be f of x is y. So I'm going to do y minus 5. So I'm going to subtract the 5 from both sides first, equals 2x squared plus 8x. And in order to complete the square, I just need x squared. Right now it says 2x squared. So what I'm going to do is I'm going to factor out that 2 in front, and then I would have x squared plus 4x when I do that. And now I'm going to complete the square. So remember, you take the b term, divide it by 2, and square it. So 4 is the b term. So I'm going to take it, divide it by 2, and square it. And I'm going to add 4. But be careful, because what I'm really doing, if I redistributed this back out, I'm actually adding 8. So I have to add 8 to the other side to keep my equation balanced. So now I have y minus 5 plus 8. So this will be y plus 3 equals 2. And now if I factor x squared plus 4x plus 4, I get x plus 2 squared. And now my parabola is in vertex form. And the vertex of this parabola would be -2, -3. So remember, backwards thinking, backwards thinking. So this would be 2 to the left and 3 down. And then that 2 in front makes it narrower. So it's a narrower parabola. So it's going to grow twice as fast. And there's my parabola. So that's option 1. Option 2 is there's a vertex formula. So there's a formula that you can use when your equation looks like this. F of x equals 2x squared plus 8x plus 5. And the vertex formula is the x coordinate for the vertex is going to be the opposite of b over 2a. And so you remember you have y equals ax squared plus bx plus c. So the b in this case is going to be 8. So -8 over 2 times a. Well, the a in this case is 2. So that would be a, b, and c. So now the x coordinate of my vertex is going to be -8 over 4. So it's going to be -2. So the x coordinate for my vertex is -2, which is what we got when we did vertex form. To find the y coordinate, you just plug that back in. So y is going to equal 2 times -2 squared plus 8 times -2 plus 5, which is going to be 8 minus 16 plus 5, which is -3. So my vertex is going to be at the point -2, -3. And then that 2 in front, again, makes it a narrower parabola. So if I wanted to put it in vertex form, now that I know that I have -2, -3, and then the a coordinate, or the a coefficient was 2, then you would have y plus 3 equals 2 times x plus 2 squared. So remember, that's your h and your k. And then the a is just from the original formula. So those are 2 different ways to get your parabola into vertex form. So your vertex and axis of symmetry. So again, to find a vertex, you can use the formula or you can put it in vertex form. So the vertex formula, again, to find the x coordinate, you take the opposite of b over 2 times a, where the general equation of a parabola is ax squared plus bx plus c. And then the a, remember, tells you if you're narrower, wider, or if you had a reflection. So if it's a happy or sad parabola. The axis of symmetry is also going to be that line, x equals the opposite of b over 2a. So that line is going to be your vertical line, which is the axis of symmetry. So the x coordinate of the vertex is also going to be the axis of symmetry. So once you have the x coordinate of the vertex, to find the y coordinate of the vertex, so to find y, plug x back in to the equation. So let's look at this. So without graphing this guy, find its vertex and axis of symmetry. So the vertex is going to be used by using the formula, the opposite of b over 2 times a, where b is 6 and a is -3. So this is going to be the opposite of 6 over 2 times -3, which is -6 over -6, which is 1. So x equals 1 is going to be the x coordinate of the vertex, but it's also the axis of symmetry. So the vertical line through x equals 1 is the axis of symmetry. To find the y coordinate of the vertex, just plug in 1 for all the x's. So this is going to be -3 times 1 squared plus 6 times 1 plus 1, which is -3 plus 6 plus 1, which is 4. So my vertex is going to be at the point 1, positive 4, and then the axis of symmetry is 1. So if I wanted to sketch this really quick, the vertex is at 1, positive 4, and then it's a sad parabola because the a coefficient is -3, so it's narrower, and it's going to be reflected, so it's going to go down. So it's a narrower, sad parabola. And that would be a sketch of its graph. Concavity. So we haven't talked about this yet. Concave up means that the arrows point up. So the parabola opens up, or it's a happy parabola. Concave down means that the arrows point down, or that it's a sad parabola. So that's the 2 different types of concavity. So we have concave up and concave down. So the parabola we just drew would be concave down. So intercepts of a quadratic function. So intercepts, and we've already learned how to find intercepts. So to find an x-intercept, remember you let y equal 0. And to find a y-intercept, you let x equal 0. And that's going to be the same for our parabola. So if we want to graph f of x equals negative x squared plus 6x minus 5 by determining whether the graph is concave up or down, and by finding its vertex, axis symmetry, y-intercepts, and x-intercepts. So is it concave up or concave down? So remember, concave up is your happy parabola, concave down is your sad parabola. Since it's a negative x squared, it's going to be a sad parabola. To find its vertex, remember we can use the vertex formula. X equals the opposite of b over 2a. So in this case, it would be negative 6 over 2 times negative 1, which would be positive 3. So the x-coordinate for my parabola is x equals 3. To find the y-coordinate, plug that back in. So negative and then 3 squared plus 6 times 3 minus 5 would be negative 9 plus 18 minus 5, which would be 4. So the vertex for this parabola is going to be at the point 3, 4. So 3 over 4 up, and there's the vertex of my parabola. And I know that it's sad, and the a-coordinate is negative 1, so it's sad and just a normal-looking parabola. I could also find other points on the parabola by the axis of symmetry, which we didn't talk about last class, or last problem, is the vertical line that would divide my parabola in half. So now if I wanted to find intercepts, well, to find a y-intercept, we're going to let x equal 0. So if I plug in zeros for all the x's, then I would have y equals 0 plus 0 minus 5. So my y-intercept is 0, negative 5. So 0, and then 1, 2, 3, 4, 5. So that's my y-intercept. I could also find my x-intercepts. I'm going to find them up here, so I have room, by letting y equal 0. So if y is equal to 0, then I have 0 equals negative x squared plus 6x minus 5. I'm going to bring everything over to the other side so it's easier to factor. X squared minus 6x plus 5. And then if you remember to factor, we need to multiply to 5 and add to negative 6. So this would be x minus 5, x minus 1 equals 0. So my two x-intercepts would be at 5 and 1. So 1, 2, 3, 4, 5, and 1. And then if you connected those points, you could see them forming your parabola. All right, so let's look at this one. Graph f of x equals x squared minus 6x plus 9. So we're going to find its vertex, axis of symmetry, and intercepts. So to find its vertex, we're going to use the vertex formula, the opposite of b over 2 times a. So this would be 6 over 2 times 1, which is 3. So the x-coordinate is going to be 3. To find the y-coordinate, let's plug that back in. 3 squared minus 6 times 3 plus 9 would be 9, minus 18 plus 9, which is 0. So my vertex is going to be at the point 3, 0. And then it is the a is going to be 1 because it's 1x squared, so it's going to be a happy, normal-looking parabola. If we wanted to find the y-intercept, we could let x equal 0. So if x is equal to 0, then I would have 0 squared minus 6 times 0 plus 9. So that's going to be my y-intercept is going to be 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if I drew in my axis of symmetry, remember a parabola mirrors on both sides. So I went 3 over and 9 up to get to that point. So I can go 3 over and 9 up to get to something called the mirror point. And now if I connect those, I have my parabola. What's the domain of a parabola? Well, the domain of our quadratics, if you remember, is all real numbers. The range, well, the y values that this graph can take on are y is greater than or equal to 0 or from 0 to infinity. Where is it increasing and decreasing? Well, this graph is increasing from x equals 3 to infinity. So from 3 to infinity, it's increasing. Where is this graph decreasing? Well, it's falling here. So from negative infinity to 3 on the x-axis, it's falling. Where is the f of x? So that's saying where is y greater than 0 and where is y less than 0? Well, on my parabola, where are the y values greater than 0? Well, that's everywhere except for that at x equals 3. So it's always greater than 0, and it's never less than 0 because the parabola doesn't exist underneath here. So since there's no y values that are negative on that parabola, then the parabola is never less than 0. The y values are never less than 0. All right, you guys go ahead and try this one, and you can check your work against the finished notes from class today. All right, if we want to write the equation of a quadratic function, you've got two options. You can write it in y equals ax squared plus bx plus c form, or you can write it in vertex form, y minus k equals a times x minus h squared. Either way would work. So we're going to do it in both ways. So if the vertex is negative 2, 4, then that's going to give us an h and a k. So this was going to be y minus 4 equals a times x plus 2 squared. So the only thing left to find is a. But they're giving me a y-intercept. So if they're giving me the y-intercept, they're giving me a point. That's the point when x is 0 and y is 7. So this is an x and a y. Now that I have a point, I can use that point and plug in to solve for a. So y is going to be 7. So 7 minus 4 equals a times 0 plus 2 squared. 7 minus 4 is 3. So 3 equals a times 0 plus 2 is 2. So 2 squared is 4. So 3 is going to equal a times 4. And then to solve for a, we're going to divide both sides by 4. So 3/4 is going to be our a. So now I'm just going to take that vertex form that was almost done, so y minus 4, and plug in the a. 3/4 x plus 2 squared. And that's going to be one way to write the equation of our parabola, and that is in vertex form. Another way is we could, well, I guess we would need 3 points. So if I wanted to put it back into standard form, I could FOIL that out and solve for y, but that would work for the equation of this parabola. So finding the minimum and maximum values of a quadratic function. Well, a graph of a parabola will have a minimum if it's concave up. So if it's concave up, then you're going to have a minimum value. And where is that minimum value on the parabola? It's at the vertex. So the vertex is going to be the maximum and minimum value. So if the parabola is concave down, so the a coordinate is negative, then your vertex is going to be a maximum value. So remember, to find the vertex, we use the equation x equals the opposite of b over 2a if it's not already in vertex form. So let's look at how we would apply this to a real-world example. A projectile fired from a cliff 50 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 40 feet per second. Oh, it is fired. So from physics, the height of the projectile above the water can be modeled by the function h of x equals negative 32x squared over 400 squared plus x plus 500. So notice we have this x squared right here. So that means it's a quadratic function. So its graph is going to be a parabola. And since it's negative 32, it's going to be a sad parabola or a concave down parabola. Find the maximum height of the projectile. Well, the maximum height of the projectile is going to be right here. So we can estimate it on the graph, or we can use the vertex formula. X is going to equal the opposite of b, and in this case, b is 1 because it's 1x, so opposite of b is negative 1, over 2 times the a. Well, a is going to be negative 32 over 400 squared. And so now, if I use a calculator to do this, so 2 times negative 32, and then divided by 400 squared, I get a small number, and then I'm going to take negative 1 divided by that, and I get 2,500. So the x coordinate for the vertex is 2,500, which looks accurate based on the graph. That looks to be about 2,500 right there. And then remember to find the y coordinate. Once you have x, you're just going to take that and plug it back in. So it's going to be negative 32 times 2,500 squared over 400 squared plus x, which is 2,500, plus 500. So now negative 32 times 2,500 squared, and then divide that by 400 squared, and then add 2,500 and add 500, and I get the y value of the vertex is 1750. And again, based on the graph, that looks good. So the maximum height that the projectile will reach is 1750, and we are in feet. So 1,750 feet would be the maximum projectile. How far from the base of the cliff how far will it strike the water. So we want to know how far over is it going to strike the water. That's going to be an x-intercept. So we want to find the x-intercept of this. And so to find an x-intercept, you let y equal 0. So 0 is going to equal negative 32x squared over 400 squared plus x plus 500. I'm going to say this probably doesn't factor, so we're just going to use our graph, or if we were to graph this on Desmos, we could find the x-intercept on Desmos. We will relearn about the quadratic formula, I'm sure later, but if you forgot it, it's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that's how we could find that x-coordinate. So the a is negative 32 over 400 squared, the b is 1, and the c is 500.